Hello fellow viewers, welcome back to another video. So yesterday I posted a video talking about what is the general formula of the binomial theorem. So this is the general formula of the binomial theorem, which is a plus b to the power of n equals to a to the power of n plus n choose 1 times a to the power of n minus 1 times b to the power of 1, and then it goes on in that pattern. And then it reaches n choose r times a to the power of n minus r times b to the power of r, and then it goes on until it reaches n choose n times a to the power of n minus n times b to the power of n. So this is the general formula of the binomial theorem. So basically today I want to talk a little bit about the formula for the 1 plus b to the power of n, which is also a binomial theorem. This is also part of the binomial theorem. So I'm going to talk a little bit about this guy's formula today. So now I'm just going to do a little visual display here. I'm going to substitute n with numbers. So let's do n equals to 0. So we know that basically anything to the power of 0 is just 1. So our answer here, I'm just going to write it over here. Then for our next one, I'm going to do n equals to 1. So 1 plus b to the power of 1 equals to 1 plus b. Now I want you to look at the coefficient of b. The coefficient of b is just 1, and the constant is 1. So I'm going to write my answer here as 1, 1. That's my second column, yeah? So I'm going to do n equals to 2 now. Now give me 1 plus b to the power of 2, which will give me 1 plus 2b plus 1. So my constant at the front and the back is still 1. But now my coefficient of b is 2. So I'm going to write my answer as 1, 2, 1. So I end up getting this, starting to look a little bit like a shape, yes? So I'm going to substitute in n equals to 3, so my fourth column will be 1, 3, 3, 1. And I'm going to substitute n equals to 4, so my fifth column will be 1, 4, 6, 4, 1. And then n equals to 5, so continue to 1, 5, 10, 10, 5, 1. So now we get this very nice looking triangle with a distinct looking pattern. So this triangle here, we call it Pascal's triangle. So this triangle here can be used to find the coefficients of this binomial expansion. But for expansions like 2 plus x to the power of 5, we need to use the general formula for the binomial theorem. We cannot use Pascal's triangle to find the coefficients because Pascal's triangle only works for binomial expansions with 1 in it. Yes? Alright? Using this triangle in examinations would be kind of impractical because it looks a bit long. So the mathematicians actually have found a way to kind of narrow it down, and so this is the general formula for the 1 plus b to the power of n, the binomial theorem. So we'll end up getting 1 to the power of n plus n choose 1 times 1, times b to the power of 1 plus n choose 2 times b to the power of 2, and then it goes on. Looks eerily similar to a formula that we have learned before. So n choose r times b to the power of r plus n choose n times b to the power of n. Looks eerily similar to some other formula. So yes, this formula actually derives from the original general formula that we learned yesterday. So how did we derive in this formula? So basically I'm going to show you. If we try to find 1 plus b to the power of n using the general formula, so now we're just going to use the general formula way, which is just 1 to the power of n plus n choose 1 times 1 to the power of n minus 1 times b to the power of 1 plus n choose 2 times 1 to the power of n minus 2 times b to the power of 2, and then you go on all the way to n choose r times 1 to the power of n minus r times b to the power of r, and then it goes on until n choose n times 1 to the power of n minus n times b to the power of n. So basically, our common knowledge tells us that 1 to the power of anything will equal to 1. So basically 1 to the power of n is just 1, and then 1 to the power of n minus 1 is still 1, and then so for the same for the others. So if we simplify this down a little, we'll get 1 plus n choose 1 times b choose to the power of 1 plus n choose 2 times b to the power of 2 plus n choose r times b to the power of r, and then n choose n times b to the power of n. Now it looks the same as this one on the top. Hold on, let me change this. Yeah, now it looks the same. It's exactly the same. So this is actually how we derive the general formula for the 1 plus b to the power of n. So yeah, you can use this formula instead of the general formula because it's easier to use if your binomial expansion has a 1 in it. So yeah, hope you learned something new today. So thanks for watching.